So hello, welcome to Short Circuits, and in this video I'm going to make a project which will allow us to control the output devices connected to our Arduino board using an IR remote control. So this is an IR remote control, and it has got one IR LED on top of this. So we cannot see IR radiation with our eyes. So how to test this? So a simple way is to hold this in front of the camera and go on pressing the keys, and if the light is flashing for all the keys, that means the remote is working. The camera sensor picks up this IR radiation, but our eyes cannot see it. This is how we are going to test the IR remote, and after testing this we know that we are going to use this remote in our project. So the next part is understanding how this remote works. So there are all other IR sources around us, like the sun emits IR radiation. Also IR radiation is emitted by incandescent bulb. So anything that heats up emits infrared. So how do we distinguish this signal from other IR sources? The answer is frequency modulation. We modulate the data corresponding to each button we press on a high frequency carrier wave. So that high frequency is of 38 kilohertz. So I'm going to explain you that technique is called pulse code modulation. So how that binary data is represented, the binary data, ones and zeros. Ultimately we are transmitting ones and zeros, 1010, string of digital data. So how that is represented in this IR communication. So this is our remote. So this is a remote control. I'm just drawing it roughly. And this is our sensor. So this sensor is a package of infrared diode. So this is the IR diode, preamplifier, and one filter of 38 kilohertz. So this is VCC and ground. This is out. So when we press this button, data like 101011 is transmitted. So this string of data is transmitted, and high frequency burst of data is sent, followed by off time. So this off time determines whether the data is 1 or 0. So if the off time is more, then we can start a timer. We can program a microcontroller such that when the low pulse is detected here, we can start a timer which will count up till this, and we can get the time. If the time is more, then the data is 1. If the time is less, then the data is 0. And this technique is called pulse distance coding. So this whole process is in general called as pulse code modulation. And that pulse code, these are the types of representing data in pulse code modulation. So by this distance represents the data 0 or 1. So the sensor plays a greater role. So this sensor filters out this high frequency. It has got an inbuilt high pass filter which passes only 38 kilohertz signal. So if suppose this data is sent is high, then the output across this looks something like this. So high followed by low, then again high. So the output looks like this because only this frequency is passed. So only for this much amount of time the output remains high. So this is called pulse distance coding. Another way is pulse length coding, in which the length of this burst is controlled. If the length is more, then if this length is more, then it's 1. If this length is short, here it's short, then it's 0. This is how the data is transmitted in IR communication. Then another coding technique known as biphase coding, biphase, in which the edge is detected. So if it's a rising edge, this is a rising edge, this is a falling edge. So there are time slots allotted. So if there is a rising edge, that's when data is 1. If there is a falling edge, then data is 0. If there is a rising edge 1, falling edge 0. That means the data is 1, 0, 1, 0. In this way, different techniques are used in IR communication. And these different techniques depends upon different remote control manufacturers. They use different protocol like NEC and RC5, or Sony uses its own protocol because Sony is a Japanese company. Also Panasonic uses its own protocol. But the two most common protocols are NEC and RC5. So NEC uses this pulse distance coding. Let's move on to the project. So here is the project made on the breadboard. As you can see, this is a TSOP sensor. This is the RGB LED connected to 10, 11 and 12 pins of Arduino. The output of this TSOP sensor is connected to one LED and it's also connected to the second pin of Arduino. So now we are going to connect 5 volts to it. The details of this project is provided in the blog, and its link I have provided in the description. So this button controls red, off, green, off, blue, off. So when I press this off button, it turns off all the output pins. So if I add all 3 colors, I get white, red plus green is yellow, red plus blue is purple, and in this way I can control colors of an RGB LED using this remote. Obviously you can control relay with it, you can build a home automation system, make a remote control robot, or add a wireless touch to your project. So this was the project. Thanks for watching. Like and subscribe and read the blog provided in the description.